Hello everyone. Today I would like to go to review diesel versus gasoline emissions. Does PM from diesel or gasoline vehicle dominate in the US? In the US, the majority of the on-road fleet on vehicle miles travel are attributed to light-duty vehicles, which are fueled almost entirely by gasoline. So the gasoline is used in the United States a lot. However, due to their significant high PM emission rates, yes, there are a lot of PM emission rate nowadays. Emissions inventories have tended to attribute the majority of the mobile source PM to contribute from which is from heavy duty diesel vehicles, and some strategy to reduce a mobile source PM have focused on the contribution from this source. Yeah, from diesel. A limited number of source attribution studies have implied that the PM emission inventories overestimate the diesel contribution, and the emission from gasolines may be greater than the previously believed. So maybe the gasoline generate more PM. Other receptions modeling study have found diesel vehicles to be the dominant source of the motor vehicle PM. The former conclusion is supported by recent on-road PM emission rate results obtained in highways tunnel and a series of crossroad experiments. This paper describes the often conflicting results obtained from receptor modeling studies and emission inventory, and use on-road emission factor results to estimate the relative contribution from the diesel and gasoline sector of the fleet. So, introductions. The U.S. has currently have national ambient air quality standard. We are known in NAAQS for the PM10 and PM2.5. For the PM standard is about 150 microgram per cubic meter, and this is for 24 hour, and 50 microgram cubic meter for annual average. And the new implemented standard consists of PM2.5 as 65 microgram per cubic meter for 24-hour level, and 15 microgram cubic meter for annual average. While nationwide measure designed to characterize the level of PM10 and source contributing to the observed level have been underway for many years. Yes, it's been studies. And recently, the National Network for Measuring PM2.5 have been implemented. There have, however, been numerous intensive studies and local regional monitoring efforts designed to characterize the levels and source of PM2.5. Based on the ambient data and source characteristics results, mobile sources are significant source of ambient PM10 and PM2.5, and control the PM emissions from this source category. It's crucial if this standard and NAAQS are to be met. This is especially true for the PM2.5, since the majority of the direct from the pipeline, tire, and brake wear mobile source PM emissions in these size fractions show the results intensive monitoring study performed at a roadside location as New York City that have a significant impact from diesel buses. Average PM10 level for this period extend to the standard 50 microgram per cubic meter. Although all loadings were below 24-hour standard. Chemical analysis of the collected sample followed by applications of reception modeling method determined that approximately about 6% that observed PM10 was attributed to diesel and gasoline powered vehicles emissions. Oh, this is interesting thing. From the chemical analysis, it can be proof that about 60% observed. Well, so this is the look in the figure number 1 that showed the results of an intensive monitoring study performed at roadside location in New York City, and that had a significant impact from diesel buses. So we are now speaking about the results. So we have 2 topics that we are talking about. This is the figure 1, show the results in average level. So I would like to prefer this article to say that 6% of the observed PM10 are from diesel and gasoline. The longer durations and more extensive. So it referred to the farm in the Denver area, which highlight the mobile source contribution to PM2.5. In this study, is about 38% of the observed wintertime PM attribute to the mobile source. One important finding in this work was the gasoline fuel vehicles contributions exceeds the contribution from diesel vehicles as the approximately factor of 3. Comparing with the European situations, this may be not unusual. May not be unusual. However, there are very few light-duty vehicle car and truck in US, while most heavy-duty car used in are diesel powered. Recently, that report results from PM2 and PM2.5 measurement performed on at 7 days at urban locations across US. PM2.5 were summarized in figure number 2, and primarily mobile source were an important contributions for all locations. Although relative contributions vary some from site to site. The Long Beach site has a higher observed ambient level but lower percentage contribution from the mobile source. And the others note that the major contribution to the PM2.5 was ammonium nitrate, and this was likely due to dioxide NOx emission from the motor vehicle. So when we look at figure number 2, PM2.5 saw contributions from 7 urban sites in the US, and list in this their concentrations. This is the location. So when we look at this, we see there are heavy duty diesel engine, there are light duty gasoline engine, ammonium nitrate. It's from ammonium nitrate. So I have no idea now what is ammonium nitrate and ammonium sulfate. A major contribution was other, and this was likely to this could be hydrocarbon, and the major contribution to ammonium nitrate. Clearly, motor vehicles are an important source of ambient PM in US, but in order to effectively control the contribution from these sources, it is necessary to quantify diesel and gasoline vehicles emissions and understand mechanism linked to mobile source related PM emissions. Primary PM emission source from their exhaust, mechanical wear, tire and brakes, and resuspensions for particle from pavement and paved road shoulders. Found road dust, tire wear contribution to PM3 to be very small. Found both PM10, PM2.5 tire wear based emission rate to be minimal or below than detection limit. Particle matter in vehicle exhaust is dominant. Particles smaller than PM10. The mobile source also contribute to atmosphere PM to the oxidations of emissions of gases of PM from pile life and evaporation loss. The primary objections of this chapter is to assess the relative contributions of PM emissions from diesel and gasoline vehicles in the US to ambient PM level. So then we compare emissions inventories in California and the US across the influence of different mobile source emissions, factor models on predictive contributions, evaluation, the result of ambient source contribution studies to compare the relative contributions from diesel and gasoline engine and on-road vehicle and gasoline vehicle PM emission rate, coupled with an estimate of vehicle mile travel to estimate the relative contribution from diesel and gasoline vehicles. A comparison of this paper exclude the contributions from resuspend road dust and secondary PM, NOx, nitrous oxide. In this presenting, the results from US gas, it is important to remember that the light-duty fleet is composed almost entirely of gasoline-fueled vehicle, while the higher-duty light fleet is composed mainly by diesel vehicles. So, inventory estimate. One of the most common applied approaches for evaluating the contributions of different sources to ambient pollution level is to prepare an emission inventories that categorize the contribution from specific source group. Inherent in this bottom-up approach is a knowledge from the relevant emissions factors, mass of pollutants per unit of activities, and activity patterns of the source. So in the US, there are two models used to estimate emissions from the mobile source. The mobile series of modeling models developed by the EU, US EP and used in 49 out of 50 states, and California Resource Board. The model used in California both rely on extensive dynamometer tests and fleet characterized stations to develop emissions factors and corrections algorithms. For example, for different speed deterioration rate, the vehicle class for each model year. It should be noted that the comparisons of the emission model predictions with on-road observations have in the past raised the doubt about the abilities of to accurately the emissions. Oh, and the agreements have been even worse for PM. Discrepancy between the model predictions based on the dynamometer test and on-road observations have been attributes to the model uncertainty resulting from lack of representativeness of the fleet used for the dynamometer test and the treatment of energy load, engine load. The U.S. national and California on-road PM emissions inventories by vehicle class and fuel type for 2000 presents in Table 1. Including these estimations, the Table 1 why emission factor used in EPL model are known. And emission factor used in California model have not been published. Emission standard for the vehicles are similar for California and for the United States and stricter in California for light-duty vehicles. This should be reduced to gasoline vehicles emissions relative to diesel vehicle emission in California. So, what is summarized? So it said about 62% emissions is from in Los Angeles, which use a lot of gasoline engine. So it's about 42% just came from the diesel vehicle. And it's the predictions, okay? And results of the source contribution study. So this say the table number 2 already, table number 1 already. So the sort of this we use alternative to the bottom-up emissions inventory method to assess the impact of the mobile soil emissions to ambient PM. Is the top-down approach examples by applications of reception modeling techniques. One such contribution techniques involves the applications of the chemical mass balance receptors model. In this approach, ambient samples are collected, chemically analyzed, and contributions from source profile use linear regression model. And the coefficient fitting the source profile provide a measure of contribution from individual source. The model failed when source profile contained many of the same chemical species, as the case the diesel and vehicle PM emission recently at one using enhanced source profile could find the difference between diesel and gasoline. Two examples of the source attribution were used. The PM contributions the name NFRAQS study performed in Denver, and in California performed the Los Angeles basin. Result of this, yes, gasoline contributes about 28%. Okay, and depending on the method, it's possible to reach markedly different conclusions with respect to contribution from diesel and gasoline vehicles. Contribution-based developments on on-road emission factors. On way to reconcile the difference observed in both emission inventory and source attributions. Approach is to apply an on-road emission rate data coupled with vehicle activity information to estimate the PM contribution from diesel and gasoline vehicles. Study performed in the roadway tunnel and crossroads experimental provide emission factor measures in the real-world setting. This approach also has a number of limitations such as limit the speed and accelerations, and most of the vehicle operate under host stabilized conditions. Still, it's allowed measurements of emissions from thousands of vehicles and avoid the difficulty of soliciting vehicle for dynamometer testing. In a tunnel study performed in Tuscarora Mountain, Tuscarora, Tuscarora Mountain Tunnel along the Pennsylvania Turnpike reported PM2.5 emission rate from light-duty vehicles and heavy-duty diesel vehicles is estimately about. So it doesn't say what is the heavy-duty. Okay. The use of various methods to evaluate the relative contribution of diesel, gasoline power in U.S. consists of results. So it's about 62% and 83%. But in some states like California, the diesel probably 33%. And opposite results obtained with previous mobile soil emission model. So I just said it. So this paper just summarized the characteristics and know that the information have been so way, and the summarize that we can get from this is the PM can be generated from diesel more than the gasoline by 10 times to 15 times.